Hello, and thank you for joining us today for this webinar, which is sponsored by the Access Forum. My name is Anastasia Papas, and I am the founder of the forum. It's a great pleasure for me to welcome Markus Leippold, Vatsala Shreeti, and Gaurav Sahu, who will discuss AI for climate policy, transforming analysis in central banks and academia. We will start with Markus Leippold, who will talk about AI, and in particular, the use of large language models in academia for climate finance and sustainability. Markus is a professor of financial engineering at the University of Zurich. Throughout his career, he has been involved in numerous projects with the Swiss banking industry and with tech companies such as Google. He is currently on the Benchmark Oversight Committee of the Stocks Contigo and the Academic Advisory Board of FEDEFIN. Markus's recent focus is on climate finance, sustainability, and artificial intelligence. He's studying how corporations communicate their efforts to combat the adverse effects of climate change. He has also founded Surreal Lab, that has developed AI-based risk assessment tools that quantify exposures to climate for corporations. Previously, he was a member of the faculty at Imperial College. Markus, the floor is yours.
Well, thank you very much for having me. I hope you can see the screen all right. So I'm going to talk a little bit about my journey over the last couple of years. And I think this has been characterized by working at the intersection of finance, climate science, and language model. And if you think back, in 1998, there was a company founded in a garage which had its mission to organize the world's information and make it universally accessible and useful. And we have come quite a long way since this one company was founded. And obviously, this company has become very, very impactful over the years with this mission that they started. But the problem is that, there's so much data around that we have really a hard time to get the overview of what is happening. And I usually call this the data deluge. There's a huge flood of data, and for us humans, it's very, very hard to extract all the relevant information, not just the information, but the relevant information that is eventually then decision useful. And this is particularly the case for climate change and nature degradation, which is probably the defining challenge of our time. So the big question is then, what kind of tools would we have available to overcome this problem? And I don't go too much into the history of natural language processing, but it's a very short history actually. So in the 50s and 70s, there were just approaches that were collecting words and trying to make sense of the so-called bag of words. And then with the first arrival of the neural networks, the tools got a little bit more sophisticated, and they were able to actually, at least to some extent, generate contextual understanding of words. But the big revolution in natural language processing actually came back in 2017 when the so-called transformer models were introduced by Google Research, actually. And these were the models that were then laying ground for other models like the BERT model, which allows you to understand words in their context, which is, of course, very powerful because think about it. I'm coming from mathematical finance, and for the first 15 years of my career as a professor, I was looking at numbers. But in the real world, there's only a small fraction of information available in numbers. About 80% at least of the relevant information is information in text. And if we have now tools available that allow us to extract information at scale from this huge universe of information, this can become very powerful. And of course, everybody is now a natural language processing specialist since the arrival of GPT-3 and how OpenAI was pushing these models forward. And everybody is using these days large language models for the good or for the bad. And the newest developments goes into the direction of agents, and I will briefly come to that topic as well. But I started my career in natural language processing actually back in 2017 with transformers, where we were then applying these tools for sentiment analysis in financial markets. But then we soon wanted to apply that to something more meaningful, which I thought at that time is definitely more meaningful, which is sustainable finance. And for that reason, we created a tool which we christened ClimateBird. Why ClimateBird? BERT, the bidirectional code representation from transformers, was the plain vanilla model that Google was open sourcing at the time. And we took that model and we made that model more specific to the domain of climate change by pre-training that model so that it understands better the domain-specific language of climate change. And this was, of course, a door opener, because with ClimateBird, we were then able to ask a lot of different questions, and each of these questions was basically resulting in papers. And our lab has since 2020 published around 65 papers in this domain. So a first kind of application that we had was developing a tool that was identifying environmental claims of companies. So it allows us to detect specific claims. And for regulators, for instance, in the EU, that was, of course, quite an interesting tool. And we collaborated on EU level with some of the institutions there. Another tool that we developed is a tool that was able to identify the net zero commitments of companies. Another tool is whether we can identify nature-related disclosures of corporate sustainability reports, because this is also something which the regulator will put much more emphasis on in the near future. And we also wanted to understand what kind of commitments are companies doing in their annual reports or corporate sustainability reports. So we trained a model that was able to identify commitments of companies and was further able to identify whether these commitments are specific or non-specific. And the ratio of non-specific to all commitments was called the Cheap Talk Index. And we developed this Cheap Talk Index, extracted the Cheap Talk Index of the MSCI World constituents, which are about 1,500 companies, over the last 10 years or 15 years. And we found that actually Cheap Talk has a real world impact, in the sense that cheap talkers are those who have the highest emission increase, and cheap talkers are also those who had the worst press coverage. So therefore, they're running some reputational risk, which eventually could have also some financial consequences in the stock market. We were then also developing a tool which we trained on patents. So we call it the Innovation Bird. And this model was able to identify whether, for instance, in earning calls, which are very important documents for analysts and investors, to understand whether the CEO is talking about green innovation or green adoption of the company, which eventually also has then an impact on financial markets. And finally, we developed a tool that you can use for real-time screening of news and identify whether there is a climate controversy, an environmental controversy of a company, which then has again some impact on the on financial markets. Something I have to say here is that we are academics and we develop these tools and make them open source available. So we, as you can see, we developed kind of an army of BERT models in the pre-generative AI time, and we make them available on Hugging Face for everybody to improve or use for their own purposes. And by now, Climate BERT, for instance, has been downloaded more than 2 million times from Hugging Face. But then came, of course, the arrival of GPT-3. And that was a real big change in the whole NLP community. I remember that at the time I was working with GPT-2 on a climate fact-checking tool. And basically, my research was grounded with the arrival of GPT-3 because all of a sudden, these tools were able to generate real sentences that were not distinguishable from human sentences most of the time. However, they come, of course, with some problem, and the obvious problem is that they can hallucinate. They have a very strong tendency to generate sentences that are well formed and might give some false indication of trustworthiness, but the models can be hallucinating to a large extent. Admittedly, in the most recent models that are also extracting information from search, this hallucination problem is has dramatically decreased. But already when GPT-3 came out in November 22, we thought that this is a great opportunity for us to apply these models to some very specific cases. And early 2023, we were then publishing Chat Climate. And Chat Climate was a tool that allowed us to ask questions to a predefined set of documents. Today, this is kind of old standard methodology, but this also reflects a little bit the half-life of research these days in computer science. But back in January 2023, we were among the first who were developing these so-called RAG systems with a use case on climate. So basically, we're using the IPCC reports and we're extracting information from the IPCC report so that everybody can access this information and also double check whether the retrieved passages are really existing passages from the original documents. But we thought that we should go on and generate something which is not just question answering, but also kind of a alignment assessment of how corporate sustainability reports are presenting their information. So you might have, for instance, a task force for climate-related financial disclosure, which is a regulatory framework. And based on that regulatory framework, you can have a check whether the corporate sustainability report is actually aligned with what the regulator is demanding. So it basically reproduces what a junior analyst is doing at, for instance, at MSCI, assessing a corporate sustainability report, whether this corporate sustainability report is aligned with regulation. And that might probably take a junior analyst about 1 day to have eventually a executive summary of the alignment and the score. And for us, it eventually took, back in 2023, about 1 hour to analyze 11,000 corporate sustainability reports and generate an executive summary for all of these reports. So that was actually quite amazing. But one problem is that it's not just about information retrieval. It's also about generating kind of reasoning of these frameworks. And one paper that we did, and I mentioned that I was very much interested in fact checking at the time, we created a system which you would probably call these days an agentic system. We called it Climinator, which is a framework that has so-called advocates. The advocates are representing a text body, for instance, from the IPCC or from the World Meteorological Organization, or an adversarial advocate from some climate deniers. And then they have to assess the veracity of a verdict, of a claim, and provide this to the mediator. And the mediator is like the judge. And the mediator will then check whether the assessment is coherent or not of the different advocates. And if not, follow-up questions are asked to all the advocates. And then some debating starts. It's like in the ancient Greek where you have this Socratian approach of debating to find the truth. So we created this kind of debating system, which improved a lot the performance of fact-checking, which could also be something very important for other fields. However, one definitely big challenge is how well are current LLMs doing in reasoning. And a field where a lot of reasoning is involved is, of course, legal reasoning. And we created for that reason probably the biggest benchmark of these, currently the biggest benchmark on open questions, open legal questions, and checked how well large language models are able to perform legal reasoning. And it turns out, and this is the good news for all the advocates, it turns out that actually the legal reasoning is not yet there, especially for open questions. Experts are still needed and they have still their place, but I only think this is a matter of time until LLMs will also have superhuman capabilities for this reasoning. Just in the last 2-3 minutes, I want to mention some agentic application that we did, which hopefully is quite impactful for, in this case, for the World Meteorological Organization or for the UN. We created, we had a joint project with the World Meteorological Organization on early warning systems for all. Early warning systems for all are on the top of the agenda of the UN. And it's about the financing of these early warning systems globally, financed by multilateral development banks and climate funds. And the problem is that it's very intransparent how this is handled, and it requires a lot of human interaction and human manpower to eventually collect all the different information from the early warning system funding around the world. They're usually classified into different buckets, but it has to be very sure that these early warning systems are funded in the right way, because $1 invested in early warning systems gives you $10 less losses because of natural disasters. So it's very important. And we created an agentic tool for the World Meteorological Organization so that they can track their funding better and more efficiently. And with our agentic RAG, we were surpassing the current large language models by a large amount. And with Gemini 2.5 as the underlying agent, we have been further increasing this accuracy up to 92%. So this is where I stop now with my presentation. Tour de force across my my last couple of years that I spent at the intersection of NLP and climate change.
Thank you, Markus. A real tour de force. So now let's pass to Vatsala, who will discuss the use of AI in policymaking institutions and in particular central banks. Vatsala is an economist working with the Innovation and Digital Economy team at the Bank for International Settlements. Her main area of interest are digital economics, industrial organization, and financial technologies. Her recent work has focused on the adoption of digital technologies in emerging markets, design and pricing of fast payment systems, AI in finance, and incentives for innovation in high technology industries. She holds a PhD in economics from the Toulouse School of Economics and a master's from LSE. Vatsala, the floor is yours.
Thank you so much. So good afternoon, everyone. It's a pleasure to be here today. Like it was said, I'm an economist in the Innovation and Digital Economy team of the research department of the Bank for International Settlements. And today what I'll try to do is I'll try to talk about central bank use cases of AI. And how I've envisioned the presentation is at first I take you through a sort of a general introduction to how central banks across the world are using AI. Then we move to more climate-focused use cases. And finally, I'll end with energy costs of AI in general. So let's first begin with the central bank use cases of AI. So how is how is AI useful for central banks? So here I'm going to show you 4 buckets of use cases. So this is from recent work from my colleagues at the BIS, who classified central bank use cases by scopes into these 4 buckets. First are the use cases related to information collection and statistical compilation. So central banks are increasingly using machine learning techniques such as isolation forests to detect outliers in large granular data sets. Isolation forests are scalable and effective, but traditionally limited to numerical data. But central banks have also been using them for categorical variables and so on. So these use cases in the first bucket, they focus on data cleaning, sampling, and ensuring the representativeness of data. So that's the first one. The second bucket contains the use cases of AI and machine learning related to macroeconomic and financial analysis that support monetary policy. So really some of the core functions of central banks. So here AI and ML techniques are used to produce real-time estimates of inflation expectations. They're used to summarize economic conditions, perform sentiment analysis of text, of speeches, and so on. And there are many examples of these use cases. So the Bank of England, for example, uses neural networks to decompose services inflation into components, capturing non-linearities, which tend to be complex, and they use granular data to do so. The Bank of Korea, for example, combines neural networks with traditional models to improve nowcasting, especially in periods of great volatility. Another example is the Bank of France that employs random forests on Twitter data to gauge real-time inflation expectations. And it so happens that their real-time inflation expectations correlate well with traditional metrics as well. So that's the second bucket, which is really core to the functioning of central banks. The third bucket relates to use cases about the oversight of payment systems. So central banks that are also payment system regulators use AI for essentially identifying anomalous payments. So well-functioning payments, as most of you in the audience might know, are vital for financial stability. But here the challenge is the sheer vastness of the transaction data available, which make this detection of anomalies challenging. So machine learning techniques have proven to be quite useful, and I'll show you a concrete example in a couple of slides of one of these pilots tried here at the BIS, actually. And the last bucket is related to supervision and financial stability, which is another core function of central banks, right? And here the idea is that supervisors need to analyze a broad range of data sources to efficiently oversee financial institutions. And often these sources are text documents such as news articles, internal bank documents, or supervisory assessments. Sifting through this, huge chunks of information to extract relevant insights can be pretty time consuming. And as the availability of data keeps increasing, it becomes nearly insurmountable. Moreover, related to climate risks have emerged as one of the new supervisory priorities. But as I'll argue also later, they lack the comprehensive data infrastructure which is already in place for traditional risks. So AI tools can be quite useful here to consolidate structured and unstructured data and essentially get insights for supervision. So here I'm showing you, I'll be very brief here, but I'm happy to share the slides later so that you can have a more detailed look. So here I'm showing you examples of machine learning use cases by central banks across these 4 buckets. I will not go into the details, but I will focus rather on 2 broad important use cases. So the first one comes from payment systems. So we know that money laundering networks exploit the complexity of interconnectedness across firms, both within and across borders, to obscure the nature of financial transactions. So what AI tools can do here is that they can improve the detection of money laundering networks. And in the next slide, I'll show you results from a simulated experiment conducted at the innovation hub hosted by the BIS. So these results, they come from Project Aurora. And so this project essentially was a pilot that uses simulated data on money laundering activities to compare the performance of various AI and machine learning tools with the performance of the prevailing rules-based approach. So even until now, to detect machine learning, to detect money laundering activities, the prevalent approach is a rules-based approach. So Aurora goes a step further and compares the detection of money laundering activities under 3 scenarios. First with the rule-based approach and then with the AI approach. In the first scenario, the transaction data are siloed at the bank level. In the second scenario, they're no longer siloed at the bank level and there is national level pooling of these transactions data. And finally, in the third scenario, there is cross-border pooling of data using privacy preserving methods. And as you can see, the results show that machine learning models outperform the traditional, simple rule-based methods prevalent in most jurisdictions. And also the gains are largest when there is international cross-border pooling of data. So this does seem like, so while this comes from simulated data, it does seem like a promising use case for central banks going forward, especially as this is an important part of the payments oversight function of central banks. The other use case that I would like to highlight is nowcasting. So nowcasting today is, most often done using pre-specified models. So the idea here is that large language models could help overcome the narrow scope of these previous nowcasting models. Recall the principle of large language models. They essentially convert words into vectors, taking into account the context, and then make predictions of the next vector representing a word. The same idea is essentially applied to statistical series, which are already in the form of numbers, right? So basically, LLMs can take a statistical series and then predict the next value. So where LLMs are proving to be quite powerful for nowcasting is that they can add structure to unstructured data. So, and this allows us to add non-standard data such as satellite images, text from social media, and so on, which provides additional context for the numerical time series. And then essentially in this way, the AI model can be further refined and trained for the nowcasting exercise. And there are several central banks that are looking into this particular use case. So that was a broad overview of the landscape of use cases of central banks. So let me end this part of the presentation by highlighting some concrete use cases, particularly of co-pilots based on large language models that are already being used in central banks. So here I'm showing you 4. So for example, the Bank of Thailand has been using LLM copilots for summarizing documents and augmenting coding, as well as for internal support chatbots. They don't use it for meeting transcription because their copilots so far struggle with language switching. So meetings often happen in Thai and English, and then the copilots struggle a bit with that. At the Bundesbank, LLM-based copilots are being used for the management of confidential information, automation of repeated queries by staff, as well as assistance in writing effective prompts for large language models. And at the BIS itself, our traders in the banking department, they're using AI solutions to automatically verify the details of trades based on unstructured conversations between traders. So it's quite useful for them. So all this to show you that there are plenty of opportunities created by AI for central banks in different domains. Now let me turn to specific applications of machine learning and AI that are focused on climate risks. And here I will present a few pilots being conducted by the BIS Innovation Hub. So disclaimer here is that I do not work for the BIS Innovation Hub, so this will be an overview, but I'm happy to provide you with further details and connect you with colleagues if there are pointed questions. All right, so the first project that I'd like to highlight is Gaia, which is conducted jointly between the BIS Eurocenter Innovation Hub, the Bank of Spain, the Bundesbank, and the European Central Bank. And this looks at the overarching problem of assessing climate-related risks when there is no harmonized data for climate indicators. So those of you that work in this field would be pretty well aware of this. So there are insufficient reporting standards for these climate indicators, and relevant data tends to exist in a very fragmented way across different corporate reports and across different jurisdictions. And adding to the misery are inconsistencies in naming conventions, definitions, again, across corporations and also across jurisdictions. So Project Gaia tries to tackle exactly this problem by combining semantic search algorithms with large language models to automate information extraction from publicly available corporate reports, and they extract information of climate-related indicators. So what it's able to do is that it's able to provide harmonized metrics across jurisdictions related to climate risks, despite different vocabularies, despite different naming conventions, and despite different disclosure frameworks. The other one is Project Virdis, and Project Virdis is conducted by the Innovation Hub Center in Singapore, jointly with the Monetary Authority of Singapore, and it focuses on financial stability, so the intersection of climate risks and financial stability. As many of you might be aware, there is a growing call for climate-sensitive regulatory oversight of financial institutions. So central banks and supervisory authorities have increased their efforts to understand the impact that climate-related risks may have on financial institutions and financial stability, and the actions needed to mitigate these risks. So this has really become a new area of focus. But we also know that these risks are pretty complex with a lot of variation across jurisdictions in impact, in mitigation strategies, as well as measurement itself, right? Measurement of climate risk. And as I also said in the context of Project Gaia, climate risk related disclosures and data tend to be inconsistent and difficult to compare within countries, but also across countries. So a comprehensive global analysis on the impact of climate risks on financial stability is very challenging. So what Project Virdis seeks to do is it seeks to fill this gap using machine learning and AI methods by building a platform for supervisors that can utilize existing regulatory data and integrate this with external climate data sources, essentially. So this the platform in this project provides system-wide and institutional level views of emissions. It also consolidates reported and modeled emissions of important counterparties to financial institutions. And most interestingly and importantly, it provides a further tool to supervisors to map the geographical distribution of entities' assets to assess the transition risks and exposure to climate hazards, essentially. There are also other PIS Innovation Hub projects that relate to climate change and climate financing. I'm not going to go into too much detail, but I'll give you a taste. So one of them is Project Symbiosis, which is handled by the Hong Kong Center of the Innovation Hub. And that essentially proposes to use machine learning methods to improve the tracking and disclosure of the environmental impact of corporations across their supply chain, essentially. Then there's also Project Genesis, which is a bit more on the climate financing side, and this involves the Innovation Hub Hong Kong Center, and this explores the technical feasibility to digitize green bonds with carbon forward. So this is a bit more on the climate financing side. And there's also the NGFS data directory. This is a collaboration between the Innovation Hub Singapore Center, the Monetary Authority of Singapore, the Bank of France, and the Network for Greening the Financial System, NGFS, again, as most of you might already know. And what this directory does is that it builds a new platform that enhances how the financial sector can access and utilize climate-related data, climate risk data. So far I've outlined the landscape of use cases for AI for central banks and supervisors, with a special focus in the second part on the use of machine learning and AI for climate-related challenges for supervisors. But as you might expect, AI is some sort of a double-edged sword. So let me spend the last few minutes discussing the energy costs and carbon footprint of AI before I end. So there is, in general, in popular media, quite a bit of discussion around the energy costs of AI and its carbon footprint. In general, though, information is hard to come by and estimates vary quite a bit. So this makes it very challenging to do any type of cost-benefit analysis of any particular use case of AI in light of its energy footprint. What we do know for sure is that not all AI models look the same in terms of energy costs. So energy consumption varies by the type and size of models, by the efficiency of the hardware that is used, by the way that algorithms are designed, and even things like how end users prompt these models. Right? The other thing we know for sure is that AI-related emissions will threaten climate commitments, and a large part of that does not come necessarily from the models themselves, but the huge energy-hungry data centers. What we know from data in the US is that the number of actual and planned data centers is only increasing. And so are the pressures on electricity and water consumption as a result of this. The data centers often cannot run on solar or wind due to the unpredictability of supply and issues of storage. So likely that a large part of the energy needs are met through fossil fuels. And these energy demands, at least in the short run, are only likely to increase until models become more energy efficient or data centers themselves become more energy efficient. Because the adoption of current AI models is going to expand, but also more intensive forms of AI-like agents will become more prevalent. So the pressure on existing energy systems will only increase. And this in part, explains the push by big tech companies to try to secure their own sources of energy, including nuclear fuel. But I do think, like, zooming out of this, the biggest challenge right now is that it's very hard to put precise numbers on any of this. Most major AI providers do not disclose their energy and water consumption, and in most jurisdictions, they are not even required to. This makes it very challenging to not only conduct cost-benefit analysis, but also make predictions of energy demands and their likely impact on climate change in the future. So I'll end my talk on this somber note, but I'm very happy to keep discussing further and take your questions.
Thank you very much, Vatsala. It was a very, very interesting presentation. I had no idea personally of all the uses of AI in all the different central banks around the world. That was really eye-opening. So our third presenter is now Gaurav Sahu, who will talk about how artificial intelligence can be leveraged for scientific discovery. I think from what we've heard already from the previous two presenters, an AI-powered analytical tool that could assist scholars in navigating and synthesizing the evolving body of literature and data related to climate economics would be something that is incredibly useful. So Gaurav is a postdoctoral fellow at Mila, Quebec, which is an AI institute, where he develops specialized large language models for scientific workflows, including automated literature discovery and streamlining the peer review process. He holds a PhD in computer science from the University of Waterloo. His research sits at the intersection of generative AI and natural language processing, with a particular emphasis on leveraging artificial intelligence to advance scientific discovery and research workflows. Gaurav, the floor is yours now.
Thank you, Anastasia, again. Can you see my screen?
Yes.
Alrighty, so hello everyone, and it's a great pleasure of mine to be a part of this esteemed panel. So Markus and Vatsala have highlighted how AI has been used to evaluate critical information in climate science, finance. I want to zoom out a bit and then talk about how AI can be used for economic research, and in particular, how we can use it to tame the recent information flood that we are all facing. So fields like climate finance, they're like rapidly evolving, and there's like thousands of new research papers published annually. This is all fantastic. However, it also poses a great problem for the policymakers, the researchers, the economists, and that is, how do we really keep up with this upcoming work? How do we keep up with this knowledge explosion? Policy makers need an up-to-date picture of the research all the time, and they also need to identify the research gaps in the existing literature. So the core problem is the big question is, how do we get a comprehensive, up-to-date picture of the existing knowledge, the key debates where people are disagreeing at the moment, and most importantly, the remaining research gaps. In this talk, we'll try to answer this question, and more specifically, we'll see if AI can help us in this case. But before I talk about all that, let me talk about a bit of basics, like what is AI, because there's a lot of hype going around it. So let's try to debunk what it is not, and yeah. So artificial intelligence is actually a really broad field, and it consists of a lot of layers, and Markus has already touched upon this a bit. So it encompasses machine learning, deep learning, NLP, natural language processing. Then it has the LLMs inside it. And then in the innermost layer, we have generative AI. This picture by no means is like an exhaustive representation of what AI is, but it only contains the most relevant topics for this talk. And Gen AI is what all these ChatGPT, Claude, Gemini, Meta AI, all these models are. So you can see that it's really like a small part of AI, and what people really mean by AI these days is Gen AI and LLMs in general. So what are LLMs, or large language models? So essentially how LLMs are trained is you pass in the textual information or textual data or raw web data from the internet to a really astronomically large neural network, and whose job is to predict the next word given a sequence. And then you have your LLM. Now, different companies have their slightly different recipes, and that results in a slightly different LLM. So Google calls their model Gemini, Meta calls their models Llama, and then Anthropic calls their models Claude, and so on. So I think LLMs can offer a solution to this potential problem that we are facing, and how we would like to, how we should think about the LLMs is, I think we should think of it as a specialized, sophisticated intern that has read the library the size of an internet, and then it can process unstructured language really well. It doesn't truly think or understand the way humans do, but it can really it can process unstructured language really well, as it's a really good statistical machine. Further discussions on this can lead to a bit of a philosophical question as to what statistics is and so on. But for the purpose of this talk, we'll keep it simple. Yeah, let's try to move on. So how do we use these LLMs to tame this information flood, as I mentioned in the beginning? So we developed our first solution called Lit LLM, which is a very simple two-step approach to accelerating literature discovery. So the first step is, so the two steps are essentially you first search the internet for relevant literature and relevant work. And once you have it, you synthesize the findings and the relevant literature. So the first step essentially is intelligent retrieval of papers. So you can think of it as finding needles in a really large haystack. So you give it a research question and it doesn't do a simple Google search. Rather, it does semantic search, meaning that it tries to put together the concepts that would be relevant for your given query. And your query can be a one-line sentence describing your research idea, or you can feed in your entire abstract of, let's say, a research paper, or you can be as detailed as you want, and it's gonna pull out all the relevant concepts related to your query, construct search queries that we then put. Actually, yeah, this slide might be might be more helpful to explain that. So once you enter your research idea, it generates some meaningful keywords, and then it constructs keyword-based search queries that we then query against a really large database to find the relevant papers. And then we sort those papers based on their relevance. And the way we do compute this relevance is also quite interesting. I'll touch upon that a bit later. And once we have that, we move on to the second phase, which is the structured plan-based synthesis of the research landscape. So to emphasize here, this is not an end-to-end automated system that is designed to do automated literature review writing. Rather, it's a system that is supposed to assist or augment a researcher, and to find, the most relevant work that they might spend their most attention on. So with that being said, let me give you a quick demo to show how it works. So yeah, here it is. You first enter your research query, and then it searches through a really large academic database. Then it fetches the papers, the most relevant papers, as shown here on top. And then the researcher selects which of these papers are really, the most relevant or most useful to understand or read through. And based on their selections, you can generate a literature review or a first draft, a really good first draft of a literature review. Let me move forward a bit. So, okay. Okay, so as you can see, each paper that it retrieves from the internet, it has some relevant scores associated with them. And the way we compute these relevant scores is we do this debate ranking, where we first ask the model to find arguments for relevance of this particular paper being included in the lit review, and then we ask it to find arguments against its relevance. And then we construct this final score based on arguments from both sides. And we found that doing it this way really improves the quality of the search results, and using a plan-based generation really helps eliminate the problem of hallucination detection. More specifically, in our experiments, we found that the hallucination rate went down up to 60%. And this is again like a slightly older result, which we did almost a year ago. Right now we have a lot of like bells and whistles associated with it, so it has gone down to almost none. Okay. So the goal of the project Lit LLM was to develop an agent or an AI system that learns to think like humans, like the way human researchers do. And then I think it's a really good tool to synthesize what's already been done. And it's incredibly valuable, but we believe that the logical next step is to use AI to help evaluate new research as it's being created. Now, this connects directly with the evaluation framework that some of the evaluation frameworks that Markus and Vatsala mentioned. So we are currently also building an AI-powered system designed to assist human reviewers. So essentially, the AI agents will help with the evaluation of the methodology, claims, citations of research, soundness, novelty, everything grounded in the relevant literature. So you can imagine it as a system that can automatically check if a paper's economic model is sound, verify if the citations are correct, and contextualize its novelty against a background of thousands of papers that came before it. And again, the goal here is not to replace a human expert. The goal is to create a super reviewer, someone who can focus their precious time on the deep intellectual contributions of a paper, because the AI has already handled the more routine and menial time-consuming tasks. And this could significantly accelerate the entire scientific process, making everything far more robust. And the picture that I've painted here, it's really like, no, it's really not proof of what the actual system. I've only mentioned a few pillars here, but this this whole AI assisted peer review system comprises of more than like 50 AI agents, each handling different aspects of the peer review process. And at each step, we ask it, we pay attention to the attribution of the model, the reasoning of the model. We make sure that everything it says is grounded in what it's being presented and so on. So it's a sophisticated system that we are currently benchmarking as well, and hopefully we'll release it. We'll be able to release it soon. But yeah, so now that we've talked about the problem and some of the solutions that we have developed, the big question is, are we there yet? After all, if AI is all so great, it should be able to solve all our problems, right? Well, the answer from my end is not quite, at least not for full automation. But I think, yes, these tools can drastically speed up literature discovery and their synthesis. Yes, they can provide a really strong first draft of literature review by helping us identify key papers, themes, and gaps that human experts can then verify and refine. Yes, they can help us manage the information overload in burgeoning fields. And yes, they can help us evaluate upcoming research. So the overall verdict here is it's a really powerful co-pilot for economists, for policymakers, for researchers in general. And yeah, maybe not so trustworthy, fully autonomous systems, not yet at least. So that was my talk. And you can find all the relevant information like the paper and the demo available on this link. You can reach out to me on this email. And if you wish to, you can connect with me on Twitter here. And yeah, I'm happy to take questions on this later.
Thank you very much, Gaurav. This was very interesting and quite comprehensive. So I would like to invite the audience to use the Q&A function to post their questions. And I have one question to start. I think what I heard from all of you is that AI applications require both substantial computational power and vast data sets. At the same time, a better climate is a sort of a global public good. So I was wondering, is there a role for international organizations to play here in developing shared data sets and some type of computational infrastructure for AI, for an AI application in climate policy, and how we could ensure an equitable sort of allocation of this type of institutional capacities, especially to emerging countries. I don't know who would like to give it a shot.
I mean, I can present my quick thoughts on it. Well, first of all, I feel it's a really complex question to give a definitive answer to. And I believe a lot of it has to do with how compliant can we make the big tech players, because we can state a lot of policies that, okay, we should have, let's say, this much budget for these many things so that the climate is good and all, but how do we make sure that they're actually being implemented and being acted upon? I think that's a really difficult part to achieve.
On international cooperation, I can add that there are instances, Anastasia, already of at least central banks coming together to explore these things in a structured way. Most of them are at a small scale, either proofs of concept or pilots. And the reason for that is, I guess, actual real life cooperation at scale is much more tricky than pilots, right? I'm afraid I don't think I have the right answer to unlock international cooperation, especially in the current political climate.
I don't know, Markus, would you like to add something?
Obviously, I just have kind of the academic perspective, and I think it's also kind of a problem on having which universities have all the resources to do research with AI, and I think there's also a gap coming up that we need to take care of in the future, but no definite answer do I have. So it's really tricky questions.
Well, I was thinking about alignment. You talked about alignment, how you're using LLMs to understand alignment of disclosures by banks with the actual regulations. There's also the alignment across policies across different jurisdictions. When different countries implement different policies, or actually policies in a different way, they can generate externalities for other countries. So there has been a lot of interest in figuring out how to align the sustainable finance policies across different jurisdictions. And I would think that would be a fantastic sort of application for some type of AI. But of course, as you just mentioned, it's a matter of resources, and it's a matter of
if I can add here, it's not just a matter of resources, but it's also then a matter of enforcement. So what we have seen in our work is that especially large corporations, they are very much aligned in the way they present their results within the corporate sustainability reports, aligned with kind of regulatory frameworks like the TNFD or TCFD. However, whatever they say in the corporate sustainability report is legally not enforceable. And then what is the purpose of having these reports if companies cannot be held responsible for their actions based on what their talk is? So I think that there are different things that need to come together in order to make the system more robust.
There is a question for Gaurav. How can research reviewed by AI be trusted and accepted by journals?
Okay, that's a great question. So first off, maybe I was not I did not emphasize it enough, but the system that I was talking about, its sole purpose is to augment and a human expert or a human researcher and not replace. And we are doing some benchmarking, some evaluation of these so-called fully autonomous, AI reviewers. And well, some results on a small scale data set suggest that they do miss on a lot of the things that human reviewers did not, human reviewers got. So, but yeah, we are yet to do it on a large scale. So, but a quick answer is the goal is not to replace, but rather augment a human reviewer, because there's a lot of things involved in a peer review process, right? Let's say if you are a meta reviewer or like an area chair or something, you need to read the discussions, really long discussions between multiple reviewers, like authors, and then you are managing multiple papers at a time. And sometimes the reviewers don't really paint a good picture of what the paper was all about, and there's a lot of problems. And the meta reviewers, they're usually like professors, and they're short on time. So the goal here is to uh, use LLMs and streamline the flow of information for them. Like they shouldn't be needed to read the full paper again and again. So that entire whole massive discussion over and over, just to like, when we have a system or technology that can do that for them, rather they should focus on identifying what the key disagreements are, and other more important aspects that actually need some thinking, and that cannot be handled by LLMs.
So we're already 3 minutes past the hour. I would like to thank you very much for this incredibly insightful and interesting presentations. I would like to thank the audience for participating in our webinar today. Just a quick note that our webinars will stop for the summer, but we're starting again at the beginning of September with Marcin Kaperdzik, who is going to talk about carbon pricing and inflation. You can find all the information on our website. Thank you very much all again. This was very interesting. So bye-bye.
Bye.
Bye.
Thank you.